All right, this last section, as it says in the program, these are conclusions for the day, and we want to talk about next steps. I introduced myself in the last segment. I'm Jeff Doyle with Fishnet Security, and we do have kind of a mix here of people that have talked before and some people that haven't talked before, so I think I'm going to go just down the row and let you guys introduce yourselves if that works. There are no presentations in this segment. This segment is really for you to ask some questions, and even though there's a bunch of us up here, there's also some presenters in the room, so by all means, you know, if you're a presenter, if you have questions for a presenter that's out there, by all means ask those questions. But this is intended to be completely an interactive session, just Q&A. So anyway, Eric, you want to reintroduce yourself?
Are you starting at this end?
Yeah, why not?
Right, so my name's Eric. You may know me from when I sat there half an hour ago. I don't really have anything to say other than everything I said for an hour and a half. I mean, I think that the wrap up here is everybody looks at this different, but there's got to be some commonality underneath all of it, right? And it's somewhere in the API-ish area. A friend of mine points out that EC2 is cool because you can get a host like that and it can do anything you want. But what's cool about it isn't that you can get a host, but that you have an API that you can get a host, right? You can make a system call to do what you used to have to at least go to a web page to get, or never mind, go down the Fry's and go buy a computer. And I think it's this opening the API and perhaps network as programmable fabric kind of thing that's ultimately going to be what we get. And everybody's going to do it different. Everybody's want to get a little bit different depth to, do I touch the ASIC, do I touch the FIB, do I touch the RIB? But ultimately I think network APIs might be where we end up settling with SDN, my take.
Scott Snedden, still from Nuage. Recruiters call often, but I haven't changed jobs yet today. But yeah, I agree with Eric. I think we shouldn't spend too much time getting bogged down into the details of OpenFlow versus white box switch versus whose controller is better than the others, and really think about the abstractions and the interaction with the users of these things, and that's through maybe a common network API. I think that's a great way to approach it.
So I'm still Jeff Mulligan. I am a recovering Washington, D.C.ite, and it does take a while. It's amazing how I've sort of understood the ills of, a little off topic, I've understood the ills of America by having lived inside the Beltway for a year. It is bizarro land there. They have no concept of reality. Just as an example, has anybody ever heard the term SUTU? No. In DC, you would all be taken out and hung because it stands for State of the Union. When the president gives a State of the Union, for 2 days beforehand, everyone's talking about, where are you going to be for the SUTU? Do you have a big enough TV? And then for 3 days after, who did shake hands and all this other stuff? And yet outside the Beltway, no one has a clue. How many of you even watch the State of the Union? Anybody? No, it's insane. And then we expect, sorry to bring us back to networking, and then we expect the FCC to make decisions about our network. Oh, come on, it's crazy. So I'm glad to be home. It's wonderful to be back, and I was mentioning we're back in the green state. Outside of Colorado, people think green means pot. So, but it is, so, and to the point here, I think that V6 and the SDN is critical for the evolution and the future of networking, because everyone's needs, whether it's YouTube, whether it's Netflix, whether it's sensor networks, where my life is, are very different requirements for a network. It's no longer this sort of homogeneous, hey, we want to serve up web pages or whatever. It's a very different network, and SDN is going to be able to allow the operators to give me a network that I need for my applications, which may look very different than a network that somebody else needs for their applications, and be able to tune that a little bit more. And I love AWS also. I'm just like, man, I can just spin up servers, and take them down in a matter of sort of minutes and go, well, that didn't work. And so I can just start all over. So that's it.
Cool. So I'm Doug. I'm the new guy, I guess, up here. I work for a company called SDN Essentials. We're a services company. We do professional services and training. So a little pitch if you guys need some SDN education. But essentially, I'm up here because I consider myself the Lorax for SDN. So I speak for SDN. I think I'm probably the only person up here whose primary way we make payroll is by SDN services. So hopefully I can give a real life view on what's going on in the SDN world. So people say APIs, and automation, and overlays, and white box switching, and open flow, and let's throw some more acronyms, but that's all cool, but what is actually going on? What are actually people doing? Obviously, it's not I'm not making billions of dollars in my company yet. Hopefully, maybe someday, but we do have some interesting deployments, and maybe I can have an interesting view on what's real and what's not. And now I know there's a bunch of vendors in the room too, so I'm going to do my best not to get every one of them mad at me. I always tend to do this when I'm on panels, but I just want to give a ground of a real world on what's going on.
Great. So I'm John Giacomoni, F5 Networks, formerly founder of LineRight Systems, and unrepentant entrepreneur. So I think the main thing I keep focusing on is that SDN is really about, and you just mentioned it, about how do you get the applications and the services running on the network. So Eric, I'm going to go one step short of the line that you were asking for earlier, which is say what it's not. Okay. While extensibility, I think, is a huge part of it, I think it is the least part of SDN. So I'll throw that out there as a stick in the ground.
So what's the most part?
The automation and orchestration of all the components in the network so you can self-provision just like you would do in an Amazon.
And I guess I didn't see them as separable things, right? If I'm going to be able to orchestrate and provision, and I can't extend that for my secret sauce and for the way that, every network is built off some stone tablets and nobody knows why what's written on them is there, but you have to follow them. And if I can get my stone tablets into my SDN, it doesn't help me. So to me, they're not separable things.
I would say that's definitely a valid point. I guess my concern is when we're focusing on the hard problems of helping define things, networking devices have been extensible basically since we wrote the first line of code. It may not be fully exposed to the end customer, but even going back to 2001, F5 was extensible and you could pull packets off the wire and do whatever you wanted. Apparently the voice of God.
No, you can't say that. Stop talking about your product. Yeah, every product is extensible. I just have to have a vendor do it unless I have, like Brian was talking about what you have, right? Mm-hmm. Coming from the place that I did, yeah, we could extend it to make the box do anything that Turing would allow us to do. It just took 2 years. So maybe it's not extensibility, it's, let me mod my own car instead of having to go back to Honda and have them do it for me. Maybe that's the right way to look at it. I don't know.
It's extensible by not having to go to the IETF and have them develop an RFC so that the vendors then go and implement it and then have it done, right?
That is part of the problem, yeah.
But to that point, one of the things Brian mentioned earlier, we'll keep talking about the guy that left. I really like what he had to say about this concept of code wins, right? If we have a framework where people can develop their own protocol extensions and additional functionality that would run on more than one router, hopefully, then maybe that helps with the standards to be accelerated a bit because we're not waiting for the big vendors.
No, I totally agree. I mean, I was just thinking about that. I've been attending IETF since IETF 2. Now you know how old I am. And I mean, in the early days, right, routing code, we talked about, running code is king. And in the early days, lots of people, Van or whoever, could be developing code because it was generally a Sunbox or something. These days, the only folks that appear to be developing code in most cases are the router vendors. And I think that SDN opens that back up to allow lots of people to do experiments, try things out, see what does and doesn't work. And hopefully, in my view, because I like sort of where the internet came from, I would love to see the IETF get back to, we only deploy stuff, we only standardize things that actually have been experimented with, actually have been deployed in some way, and we do have some experience with it, as opposed to these days we tend to, sorry, I'm a little down on the IETF these days. These days we tend to standardize on some things because the vendors that, have, oh, well, this is a good thing, and they sort of push this through the process. It becomes an RFC, and suddenly, okay, that's the standard. And I think we've gotten behind ourselves in some of that. So I totally agree with you.
I'm very curious who these people are that are going to develop all this, actually. And I think you made a point with that as well. When you look around the room, I don't know how many people in this room are going to start grabbing some bare metal and experimenting, because who has the time?
Ryan is.
Yeah.
I talked with him. Ryan's going to.
There's a few. Look at who's driving some of these. We have Open Daylight driven by vendors. We have NFV driven by providers. So I think in order for this to work, and this is actually, not to plug what I'm doing with my customers, but we talked about different jobs and how the network engineer face is changing. So I personally think in order for this to work, we have to start tackling the huge network engineering base out there and get them on board to start changing their job description a little bit and have them stop becoming configuration engineers and become network engineers again.
Go ahead. I want to make a perhaps offensive demographic point. Back in the early days, when it was MPLS versus ATM, I was at a customer meeting, and you could tell who the ATM guys were because they were the guys in suits, and they sat on this side, and the IP people sat on this side, and they had long hair and ponytails and ripped jeans. And I look around the room, and the median age is not 23, and there's very few ripped jeans here. I think you want to talk about experiments, it's going to be those people. I think perhaps it is our job as network people to give them the ability to do that. That means giving them jobs, right? And Google will be better at that than I am, because we're not that kind of shop. But in general, maybe that's our job, is to provide the infrastructure for, reformed script kiddies to do cool stuff that we haven't figured out yet.
But right, folks like, when Van was doing a lot of his stuff, he wasn't doing it at Cisco, or he was doing it at Berkeley. Right, and so I think who's going to do it? I think it's going to be a lot of folks at universities, if we give them the opportunity and the ability to, whether it's Stanford or someplace else, the ability to do that. But also when you say, well, it's still vendors. No, it's a different set of vendors. It's not just the router vendors. It's Comcast. It's the people who have and need to deliver a service who are now doing more experiments with things and pushing the envelope of saying, let's just try this and see what happens. And they have a very strong incentive to get something that works, because suddenly they lose 1 million customers. Not a good thing for their bottom line. So I just think, and I think the internet was an experiment, and I think SDN gives us the opportunity to do some experiments in that same space. Now it sort of does scare me a little bit about what about nefarious code that can make its way in and do things that secondary effects that you don't, and I think we need to deal with that. But to me that wouldn't slow us down from getting some of this stuff deployed and making more things available and being able to do more routing experiments.
No, I think that's a very important point, is that for people doing the experiments have to have a reason to move it forward. Back in the day, in the Berkeley Stanford days, they were doing it because they needed to get connected to the internet, and that was the service they were doing. Now that the world has matured significantly, we have high-value services running on the networks, the concerns of the type of connectivity they were hacking on back then are very different from the ones today. So yes, I think we need to find a way to encourage level 3s to have their ripped gene hackers coding away, but also the VIA West and the other folks who are building orchestration systems for end consumers, the Amazons. They're the ones who are really going to paint the way for what products need to look like.
But didn't SDN really originate exactly the way you say? The early joke was SDN, stood for Stanford Design Networks. It came out of university environments of people saying we want to code, we want to, we want to create our own routing algorithms and all of that, and we can't really interoperate with vendor products enough to be able to do what we want to do. But then don't you see this as kind of a natural progression of, okay, we've got that early academic route, but that has to go into standards bodies, it has to have vendor support because, whether it's existing standards bodies like IETF or whether it's specially created standards bodies like ONF, but you also have to have that vendor participation to really get it into large user networks.
So Jeff, I'm going to make a comment here, which probably will get me in trouble, but as a cynic recovering academic who never actually finished his PhD, stopped 2 months short, thank you very much, I think there's a fundamental problem of incentives. So when it came out of Stanford, they were definitely working on a key valuable set of problems, but it was driven by the academic literature and what the funding agency was saying, go play with the routing. As we move it out into the world, it's a much more complex world than that narrow focus.
Yeah.
So we need to take the idea, but move it well beyond where it started.
Yeah, to move it forward, you got to have a business case.
Yes.
What is a business case?
Making money.
Or saving money. Yeah.
Right?
I think, well, yeah, sure, but I guess we can talk about that piece. Whenever you see SDN, you say, oh, you're going to save so much in CapEx and OpEx, and you see that in every product since like 1975, right? So we can argue those merits. For what we've been working on for our clients, it's mostly about making money, right? So it's like, okay, we're now competing with, like, maybe we're a tier 3 ISP, and now we're competing with AT&T and Verizon. So we need a way to, create some service that competes with them that's either better, faster, or new for them. So I think some of those are old services that they just weren't able to do before, maybe because they didn't have enough money. Some of them are new things that are kind of being created off of the think tank. So I think that kind of answers your question a bit. But
Let me throw another piece at that might help. So one of the things I was chartered to do was go figure out the SDN and NFE story, because if we didn't have one, we were going to look bad. This is just the same point I made with MPLS, right? You have to have a story because you need a story. So I get on the phone with some big customers, and they said, what's your story? I said, well, SDN and NFE are these giant building blocks, and we have plans to get our hands on the building blocks. What do you want me to build you? And they went, crap. And that was the end of the phone call. So maybe it's just the business case is simply being ready for someone who knows what they need more than I do to tell me what they need, right?
Yeah.
Instead of handing them a finished product and trying to sell it to them because it's what I have, I hand them, whether it's APIs or whether it's something else, and say, go figure out what you can do with this, right? Here's small Legos, right? It's not front half of a boat, back half of a boat, click, you're done. It's a bag of things. Maybe that's the most business case we have.
yeah, I mean, well,
It's shaky, yeah. But so is MPLS, and it seems to have stuck.
But I mean, it's a good point, though. I mean, network engineers today, most of them I know and have worked with, you design your network based on some box or series of boxes you have, and whatever features are in that box drives what services you have. This is like a humongous paradigm shift that's going on in the industry where well, let's think about the other way. Like, let's think about, I would really love to, I don't know, do something basic like, I'd really like to have per user bandwidth with a firewall spin up and some load balancing in there. I can't do it on my Juniper and Cisco or whomever, but okay, that's what I want. Now how can I actually build it? And I think that's the business cases you have to build with SDN.
It's sort of, I think, a term that you guys are.
I mean, there is a business case if somebody pays for it, right? Otherwise, if nobody pays for it, it's a hub. I'm not saying technology is bad. I'm saying it's a how we're going to deploy if nobody pays for it.
We don't know.
That's a
Yeah, but sometimes people build things on a leap of faith, right? And experiment. The term that I've heard recently is that's not true. YouTube wasn't the guy. No one, right? I don't believe that YouTube said, oh well, we know what this is going to be, or Facebook or any of these things. What it was, and it's the term that I'm trying to get to, is permissionless innovation. You can create innovation inside, say, the routing infrastructure or across the internet without necessarily having to get permission from Cisco or Juniper or somebody else. You could try to build something. Most startups are doing just that. They're out there and they're just taking a leap of faith.
I beg to differ that most startups have somebody that gives them money
because they convince somebody they're going to build something that's going to make money.
Absolutely.
Right. So,
but there's no proof,
as
there's no
opposed-
guarantee of that.
Absolutely not. But all I'm saying is that without that, it's a big hurdle, right?
Well, we know it's a big hurdle. If it wasn't a
Right.
big hurdle, we wouldn't have all these conferences and all this slides, and everybody differentiating
If
and
it weren't a big
disagreeing,
hurdle,
right?
it'd already be done.
Right. So one of the best explanations
Well,
I've
I
ever
mean,
heard for...
you can say that, but the point is that still, to make it pragmatic and to make it real, it needs to be out there. And for it to be out there, technology, it needs to show that either saves costs, saves money, or makes money. It's that simple.
Right,
No
but
argument there.
SDN isn't a product.
Right.
It's more of a conceptual architecture for how you build and design networks. And all we're doing is building the components that people need, the Lego blocks, to build what they need. So this trying to define SDN as, here's specifically a protocol, here's specifically a building block, I think that's short-sighted. Because a carrier needs something very different from a web monster, which is very different from a financial hosting 10,000 applications on a single network. So again, it comes down to, let's give them the tools, the frameworks they need to be able to innovate.
Scott, what do you think? You're just waiting until this is over so you can go home?
No. I was gonna throw out another topic in a few minutes here, but I mean, to that end though, you know, what we're seeing, what I'm seeing in the market with the customers that I'm winning are people that are looking at an opportunity, a service offering that they could create. And it's tough to go say, I'm going to compete with Amazon Web Services in North America, but in parts of Asia, you can still get away with that. And so I see customers saying, hey, AWS looks to be making a lot of money. Amazon certainly is. What if I were to offer some sort of cloud service? And then when I go look at what AWS did and how I can spin up a VM and create a network in the cloud and all of these things, people come back and turn to their vendors and say, how do I do that? How do I turn up a cloud network and make things? And so that's where we're getting traction with these technologies. But we're not going to these customers saying, buy SDN. We're going to these customers saying, well, what's the service you're trying to offer? And we have the building blocks to help you do that. For a large enterprise, it could be looked at as a similar way. All of my developers are using Amazon, and I don't know where my stuff is, and suddenly their expense reports are gone through the roof because they're billing all their AWS charges on their credit card. How do I rein that in and try to build something that's AWS-like? And so I think you can start to look at innovative services and startup-like things and think, how do I bring some of that in-house for my internal consumers? And the use cases for that might be few and far between, but I think there are a few of them out there. And it's not a, I'm going to push OpenFlow on you. It's a, what do you need to build? What do you want me to build for you? And then let's figure out how to build that. Well, and that's the thing. I don't have a really compelling business case to say you need to buy Nuage SDN. I can help you with a business case to say, here's why you need to bring your cloud services in-house, and then I can help you build that, and hopefully you pay me a little bit for that help, preferably in terms of software licenses. But yeah, I mean that's kind of where we are with this right now. You can.
So do it without. No one's making you do it with.
Yeah.
You know?
I'll argue you can do it better with SDN, but
I don't know what it is. You guys are past me.
Another topic?
So, on the topic of standards bodies and things like that, what do you guys think of the work that's happening in OpenStack and projects like Open Daylight? Do you think these are a platform for this kind of fostering of innovation, that we could start to see things move forward in a way that maybe isn't the IETF but becomes a de facto standard?
Yeah, I think they're great crucibles for figuring out what does a controller look like, what does a higher order orchestration system look like. In fact, look at the OpenStack environment. It's already being forked in a number of different ways. You have startups going in and ripping out, say, the networking layer to make it better because apparently Neutron is dead on arrival again, whatever. But the point is there's a whole lot of innovation that's going on. And is it going to be IBM's OpenStack? Is it Red Hat's? Is it HP's? Is it the generic one? Is it the Mirantis one? There's a whole lot of innovation going on. So I'm actually very hopeful that this will actually produce something that is useful to a broad swath of the market. What I don't know if it will come out that a lot of customers are looking for is a standardized set of APIs.
Yeah, I mean, that was, I was involved in Open Daylight in the very beginning. I was at Brocade when this whole thing was established, and that was one of the tick marks that was a very high priority. I haven't seen a lot of progress on that. But
Well, if you're a vendor, I mean, just to be honest with you, if you're a big vendor, do you want a standard API, really?
well,
Really? I mean, probably not.
You come up with standards and then your own proprietary extensions, right?
Exactly.
I mean, if I can touch on the open source thing for a bit, it's great if you're Google, it's great if you're Facebook, it's great if you have the tools to do it. Again, I'm a lean shop, we do more buy than build. I'll use open source, I'll use Python, I'll use GCC, because the community has made it work to the point where I can use it. But yeah, how many OpenStack flavors are there? How many open ODL branches are there? This is what's killing me, and it's kind of what I meant in my slides, right? Solve that thing for me so I don't have to think about the parts that I'm not good at, right? And the fact that everyone's got their own ODL and their own OpenStack and their own, this guy participates in this guy's ecosystem and this guy's in this guy's ecosystem. And I don't know this is hard, right? Just figure it out, open source has a cost, and I don't have the people to pay that cost. I'd like to pay somebody to solve my problem for me, and I don't know who's out there and how they're different, right? It's a hard problem from the buyer perspective.
see that, yeah.
So what do you think the answer is, really? Do we have to go focus down onto, like, say, one version of OpenStack? Or is it one API? What is the common thread that would make you happy? GCC works because it's really implementing C, which is a common API.
It works because it's been out there long enough that people have put enough things into it that it works for everybody.
Yeah.
Right? There's God knows how many switches and knobs you can do for all the things, right? The problem is it makes me be last mover, because it means you need 7 different OpenStacks and you guys all fight it out, and then somebody comes out with one that is the superset that does everything, and then I use that. But that means I don't get the right tools until then, and I have to either, build the bridge as I'm walking across it or wait for somebody else to build it for me. That's hard, right? That's commercially painful.
And the word API is a tough one. It's an easy one to throw around. People love throwing around the API, but where the hell is it? There's a big latitude and longitude you have to look at.
Yeah.
Are you talking on top of a router or switch, controller, on top of OpenStack? Are we going to the right? Are we going to OSS and BSS systems? So where the heck is this API, and how many of these do I actually need? Do I need 3, or do I need 75 of them? And I think this is why there hasn't been a standard API yet, because we haven't even figured that part out yet.
I think Sam's got a thing.
So even if you do not like open source because of many flavors, the other option is having vendors implement their own flavors, which is again unique to the vendor.
Unless
So-
I find like a Red Hat, systems integrator,
Exactly. So
Accenture type.
they
person.
should be, I think that's where I'm leading to. So they should be a system integrator kind of who will vouch, saying that this API will work and they're going to bake it or something like that. But I have a different question though. Like it's more geared towards operators, putting my vendor hat on, but not speaking for vendor. Let's take you have, as a vendor, I provide you with all the API and what all the bells and whistles that you could operate on.
Yep.
Now, have you considered who is going to vouch for your network stability?
Stability?
Yes, for example, the device. Let's take, as an operator, you want to program the device,
Yep.
right? Who is going to vouch for your stability of the device? So those are some things, as an operator, have you considered as a hindering block for your SDN implementation in the network?
Stability, so the device performing as required is an
Right.
issue
So for
whether it's
example,
SDN or not.
let's take MPLS. Okay, that's
Okay.
easy to talk. Okay.
I'm familiar with it, yeah.
So if there is a problem in the control plane of MPLS,
Yeah.
right? All you do is, maybe in the case of Cisco, you call it TAC, and they're going to fix for you. If there is a cap case, there is some financial agreement. But now we provide the API. Who is going to own that responsibility?
If I buy a piece of gear, I expect it to do what it's supposed to do, right? And in theory, again, API is a fuzzy word, but if you've got a well-defined return value and a small functional thing, maybe it makes it easier. But ultimately, to my customers, I'm responsible for stability. So it's my job to get the right ecosystem-y stuff and make it do what it's supposed to do and make it do it well. Right? It's my job to build the network.
No, I totally agree. I'm not denying that it's a responsibility to keep the network stable, but where do you draw the line? Like, who is responsible? Is it vendor's responsibility, or is it the third party who is providing you the stack or whatever you call to run on the device?
Yeah.
Or is it the network operator's responsibility because now you are playing with the API and you could.
This is just like building a multi-vendor network. And I've not built one, I've only been here half a year, but I've been on the receiving side of it for a long time, and I know how hard it is. And it's part of the challenge, right? I can build a multi-vendor router network because I know how to play that game. I don't know if I can build a data center that runs router functions because I don't know where to draw that line.
And-
Right? And everybody draws it differently.
And Sam, until you have some more standards, APIs, we'll throw that word out there again, you can't make that delineation. I mean, today, if we're doing BGP and my BGP is not working towards my router, I'm calling that vendor because I have a standard that says, hey, I just sent you this update message with, I don't know, extended AS numbers and it's not working, so it's your problem. But now, yeah, it's an impossible question to answer because it's an API that is not standardized, so yeah, where is that line?
Yeah.
And that's I think one of the big things that the industry as a whole has to tackle.
So actually, let me ask a question that's dovetailing on this API question that comes up periodically in my conversations, which is you have APIs which are used for two things. One is for integrating with someone else, and then the two products do the integration. The other, as we were talking earlier, is you get the RipGene hacker to stand down and start working. And there's all flavors in between. The question is, as you get closer and closer down to being a data path engineer in your NetOps team, is there sufficient knowledge base for companies to be able to hire that? Can we actually populate all of our NetOps teams with enough engineers who can actually write good code and keep networks up and running? And if not, how do we get there?
I think we can build it. I think we have a lot of network expertise that we didn't have 20 years ago. And I think that's, for most of us, everybody I know, certainly for me, it's accumulated organically. If you give me a good programmer and I can teach them enough about the network, and this gets to a point that was made earlier about how much do you abstract it, right? But give me a person who's good at one and I can make them good at the other. And then in a generation, this becomes, it's like medicine, right? You get more and more specialized, but you still need a generalist.
Well, I'm going to pick on the point of, you made a key requirement there, good programmer. There's data path engineers and then there's normal programmers. Because of the constraints when you blow up are really, really different. The scalability and the tolerances are very different from, say, someone who's writing an iPhone app.
Sure, right. GUI developers are different from firmware developers, right?
Right.
Give me someone who's good at what I need them to be good at. I don't really know how to answer that without going in a circle. But there's two pieces. Give me someone who's good at one piece, and I can build the other piece with them if we decide it's worth the investment. It's like anything else, right?
It sort of is, but having just built an infrastructure company, we've been building infrastructure companies for a long time, and the common complaint is, I can't find good engineers to build this stuff. So the question is, are we walking ourselves down a rat hole by exposing too much functionality that we actually will never be able to service?
Yeah. Sure. Might be. Don't know.
Well,
What do you guys think?
I don't know. I'll take an optimistic view and say that if you expose it, they will come. And I sort of have this belief, right? I mean, I don't think that someone who's a network engineer can be a good routing programmer. Somebody who's going to write code that sits inside the router and knows how. I think that's going to be specialized. But I do believe that if we expose that opportunity for younger people in school to start to get back to start to experiment on that stuff, then they will come out and they'll be the folks that you hire in the next generation. I think the other thing I'm just wondering is maybe we have mixed expectations of how long this should take. That I don't think that this is, SDN is going to be this overnight success. Tomorrow we go click and all of our world zills and routing are solved. That this is a fairly long process of a new way to look at how to build networks, how to build and not just networks, how to build the equipment that sits inside these networks. It's new, and it's going to take a little bit of time for us to develop the expertise to write the code, for the right folks to build the code. We're going to make a few mistakes, but to get back to his point, I think that yes, everybody has a view, right? We're not doing this, except for maybe people trying to do a PhD. Most people aren't doing it for free. And so they're oh, sorry.
That's why I started Line Rate, don't worry about it. I got myself covered.
So I think the goal is but at the end of the day, obviously, to make money or get new customers that makes money, or new services that makes money. The bottom line is makes money, or saves money, but saves money is makes money. A dollar saved is a dollar earned, I think Ben Franklin said. So I think we have this expectation that it's just going to happen so quickly, right? That everyone's an overnight success. SDN will be an overnight success. It'll just be there. It'll all happen. It'll solve everything quickly. I think it's going to take a little bit of time. We're going to need some experience, and I think we do need to. But I do think we need the building blocks, the Lego pieces, for folks to get out there and start to do this sooner rather than later.
It kind of leads into a question I've got for all of you. We're talking a lot about futures and development and all of that, and even, how do you define SDN? But do any of you see SDN deployments out there right now, in whatever form? I mean, there's controllers out there existing, whether they're open source or something like, Juniper's Contrail or something like that. Do you see people profitably using those things now?
Isn't Internet 2 doing that?
No.
Well,
No.
you have the shirt on, don't you?
Exactly, yeah, but I got this back from the IPv6 days.
Oh, okay.
I'm seeing deployments. I'm
Yep.
seeing people starting to slowly reap the benefits. It's just been this year, from my firsthand knowledge. I worked for Viata for a little while before I went to Nuage, and we had thousands upon thousands of people downloading the Viata virtual router around the world. And so by the stretch of our marketing department, I guess you could call that SDN. And so, yeah, people were using that, and they're seeing the benefit of not buying a Cisco branch router. So it's cheap, it's free in some cases. So yeah, there's a benefit of leveraging what has become software-based networking and commodity hardware. Yeah, okay, that's starting to happen, but it's not massively widely deployed.
Yep.
I think the only ones that are seeing and reaping major benefits out of this are the Googles, Amazons, Facebooks of the world today. But like I said earlier, it's changing slowly.
Yeah, I can say too, I mean, this is what my company does. I mean, we are doing deployments, it's real. But that also kind of brings in what SDN definition is. But what's been interesting and fun actually for my company is, we sometimes go into these engagements and it looks just like a standard routing switching engagement. And you get to the point where like, well, this box doesn't do that. I'm like, cool, no problem. Let's think a different way to do it, and let's bring some automation, some programmability, and maybe even another abstraction layer and fix it. And that's not a conversation that I could have had 3 or 4 years ago. And it's just starting to happen more now for us. I mean, in the beginning of this year, we were doing a lot of education and maybe a lot of POCs. But in the last, call it 90 days, we're doing deployments. Now, it might not be classic open SDN with a controller and these switches that all they do is they're really dumb and forward packets and all that piece, but it's the migration path to get there, which might be the fact that we're now using APIs. It might be overlays. We haven't really talked about overlays yet. I have my opinion on where those reside, but those are happening, and those are a path to get to probably the point we want to get to. And to your point, I mean, it's going to take a few years for us to probably move in that direction.
Yeah, and I'll go, if you take the definition of SDN as really being this operationalized network, where it's an architecture framework to get control of your network and essentially manage for them, yes, the web monsters have been doing it for years. A lot of the hosting providers from Amazon, and it's been trickling down more and more. It's not a commercial product, but they've built their own products to do the whole thing because that was their IP. Same thing we're seeing in the financials. A fair number of them have built their own. Do they want to rip and replace so they can call it SDN? Probably. But that's more of the financial analysts are saying, hey, do you have an SDN story? It's like, oh, we need to change something so we can have our SDN story. But this is why I was kind of asking the question. The first panel is, I think for large segments where a lot of SDN has applicability in the not too distant future, they're already well on the way to adopting and implementing.
Some form of SDN.
Yeah. But again, to me, SDN is really an architecture. It's how do you want to build a network to accomplish your business goals? So you should have this automated stuff and you're not actually touching the data plane. Because that's when your fat finger typos start happening.
So if you call it that, we've been doing it for 15 years.
Exactly.
We have a video backhaul service, does all the major sporting events everywhere. And apparently what people do, and I don't know too much about it firsthand, they go to the webpage and say, this event, this size, streams to here, this date. It's bandwidth calendaring, and it goes to a thing that decides whether that's okay, and then it configs what it needs to on the routers, right?
Mm-hmm.
Somebody show me that's not SDN, and then I can say I'm not doing it. But it gets back to this nebulous, do
What's
it and then
SDN?
define it. Yeah.
Yeah, I would definitely count that as SDN.
Then I've been doing it longer than it has existed.
Good job.
Not me, but
So it's here, it's all done, let's go.
The word of these conferences.
I mean, the carriers have a different level of scale and aversion to risk that makes these things a little slower to adopt in the WAN. I can make a change to a 1 gig interface in a data center and it's not going to take out a bunch of things. But if I affect one of those 100 gig waves, there's a lot of stuff that happens if I screw that up. So it's going to take time for things to trickle there. There is a massive segment of enterprise that listens to the gospel of Gartner and only listens to the gospel of Gartner. It's going to take time for them to come around too, because we're going to need really, really well packaged, supported services and solutions that they can point at their vendor and say, you have to go deploy that for me. But for those in between, that's where we're seeing innovation.
So Doug, you brought up, you kind of touched on this. There's sort of been a trend in data centers with sort of going to a dedicated fabric, and then, it seems like overlays are sort of, in some ways, becoming the new virtual fabric in data centers. Do you guys see SDN as sort of the next step along there of replacing overlays, or is this just going to be a new way of managing those tunnels underneath?
Yeah, I'll start there because I'll get myself in trouble first. Everyone else can bail me out. So we have many projects where we work with overlays, and they work. They do. I haven't particularly done any nuage or anything, but it works. But for me, I consider it a stepping stone to an end goal. I mean, I think we have to learn a little bit from our mistakes in networking. I think we've learned a little bit about overlays in the past 25 years. What we've learned is we always replace them at one point. And when you look at what overlays are doing now, from the networking space, it's providing connectivity to solve some problem that my network is not solving for me, right? So, let's talk about multi-tenancy and trying to have a single layer 2 domain, right? All those pieces, it's not really solving some of my underlying problems I have with the network piece of it. It's just kind of putting a Band-Aid on it. I think personally it's a very, very important step in the process, but I think it does have an end. So I apologize for all the overlay vendors out there, but that's my opinion.
Let me just say, as an overlay vendor, that I agree with you. I will not deny that. Grappling something into an IP tunnel and sending it across 20 or 30 switch hops is not probably the most optimal way to do things. Does it work? Yeah. Will it work for a really long time in some cases? Probably. But there's a lot of stuff out there that can't de-encapsulate that endpoint. You need a way to do that.
Yep.
There are a lot of things that have to happen underneath that IP tunnel consistently and reliably for that IP tunnel to even exist. And if I don't have a way to correlate and troubleshoot those things, I'm just creating more problems than I'm solving. So yeah, I totally agree. It's an interim step, and it's probably a permanent step for some use cases, but it's not the end goal. And I think we want to figure out other ways of encapsulating, other ways of actually doing hop-by-hop management of network resources. But it's helping us gain adoption of some new operational models that hopefully help drive some of that other innovation down the road.
definitely.
I'm going to go the other way, because what the hell?
It's late.
Yeah, so we talk about abstraction layers. We talk about, I'll take care of your thing, you just take care of your thing. Isn't that an overlay? Right, the whole point of a tunnel is you don't have to think about the underlying fabric. But if I have to do SDN and chain hop by hop and manage all those hops, haven't we just gutted the whole API thing we've been yamming about for an hour? Like, what's the difference?
Well, you have an API to set up the overlay mesh that you need, so then you can then orchestrate the other network elements that run on top. You're just creating programmatically using an API to create a fabric for yourself for your particular service, so that qualifies, and then there's all the rest that you have to manage on top. And then you also have to go somehow with the orchestration system, give hints to the underlying saying, hey, I might actually need quas on this.
Yeah, I think it's about visibility, that's part of the difference. I mean, it's okay, I can build a tunnel on top of a tunnel on top of a tunnel, but what can I actually see? So if I have an orchestration system that's building all that for me, I build it right, I better see what's going on because I built it. I think that's, for me personally, that kind of differs what, we're talking about an overlay with VXLAN and or whatever compared to maybe what you're talking about. I think it's the visibility piece.
Salvi, a quick question. And this is more long-term, the future of the internet. We use today IP addresses in DNS. Do we think that's going to disappear, let's say in 5, 10, 20 years from now, and so it's going to be, SDN is going to be we were just not going to need IP addresses in DNS. Is that something that you've considered? There's some books out there on that.
20 years? We're having a
I'd
hard
say
time
10
getting
years,
to
yeah.
2, dude. I mean, look back where we were 10 years ago and think if you could have predicted now. I don't know. Yes or no. I don't know. Pick your favorite.
I mean, I think, like Van's work on data-directed network, or Xerox has some work on content-directed networking. I think, yeah, I'll be long gone. Yes, we will not have IP addresses 20 years from now.
Yep.
Okay, and hold me to that.
But you still need some kind of naming scheme.
Something.
Right, but I'm really enamored with this idea of content-directed networking, where it's not to a machine, it's to the content, it's to the data that I need to get to, wherever that happens to be amorphously across some internet cloud or something. And I think that we will see the future internet, not IPv8 or whatever, because we skip odd numbers, right? So I think, if we talk about the long-term future of the network, I think it would be kind of interesting to think about how software-defined networking we're routing about data, not routing about IP addresses, and that'll be sort of an interesting. Again, I think we need, if we talk about this, we need the architecture for that type of experimentation for us to try it out and see whether it makes sense and see whether it's going to work and see how those things work. And so SDN might allow us to evolve to that.
Yeah, you have to think about why we have IP addresses today anyway. I mean, why do we have an IP address? Why not just MAC addresses, right? I mean, I think the kind of looking at history, it was a decision of scale, aggregation.
Although arguably, right, there's more MAC addresses available than there are IP addresses.
There are now. But back in the day, you couldn't store that much in your little memory of your router or your switch. So there always has to be some way to identify, obviously, the flow you have, but it doesn't have to be an IP address. Probably not. It could be something called foo.
No, it's just a universal label for something.
Yep.
MAC addresses are generally tied to the machine, so if you move them, that actually has implications. IP addresses, yeah, you can inject a CIDR block route and move the whole thing, but it's a very different scale from moving the prefixes for a MAC address. So it's just a layer of abstraction that gives a name to something. And then he goes through a proxy, and suddenly you're actually dealing with 10,000 machines, 100,000 more if you're Google, all coming off like a handful of IP addresses. It's just a label for naming things.
Right, but I think the point, DNS is a much more extensible label for naming things, right? It's relatively infinite. I mean, V6 is basically infinite, and but DNS is even more. And so you'd have to ask Vint why they actually gave it, why they picked, that as opposed to MAC addresses or whatever. But I just think the idea of saying I just want to get to some, I mean, at the end of the day, we want to get to a piece of data. I don't want to get to a server. I don't really give a hoot whether that what the IP address is, or frankly, I don't even really care what the domain name is of that server. I just want this piece of data. I want a YouTube video, and wherever that happens to reside, I think that'll be sort of an interesting thing because it could reside in lots of pieces in lots of different spaces. But again, 20 years from now,
We're not going to have it's not going to be called SDN either.
yeah,
Right.
right.
It'll be something new. You have a whole different conference.
We got to stay in business,
What we will have is conferences.
Yes.
There will always be opportunity to take
20
part in
years from now, there will
conferences.
still be conferences.
Yes, it's a service provider question, so Eric, I guess it's you.
Yeah, I guess.
As you guys look at NFV and you decide which of the functions you're going to
Which of the functions you're going to virtualize. You have SLAs you have to maintain.
Yeah.
What about the availability aspect and which boxes need what level of availability? Is that being looked at? Or, well, let me ask, is that going to be a problem? Has anyone?
Yeah. Of course it's important. Have I
I
looked
mean,
at
a problem. Do you see it
it's a
as a big problem?
Is it a problem? Well, so this gets to the data center heritage of a lot of this stuff, and it was a point I tried to make in my slides. Hadoop cluster, you get a hard drive go bad, you rip the hard drive out, you throw it in the shredder, you walk away, and you just kind of redo that bit of the job. If it's a firewall and that goes bad, that's you either fail open or fail close, and either way you failed. So we have to look at, clustering may be more important if we run this on commodity hardware, which may be an argument to do a variant on what Comcast is pitching. Give me enterprise-grade hardware so that I don't have failures all the time. I'm very much a walk before you can run guy, and as we move from slideware to kicking the tires in the lab, I'm not looking at life cycle management. I'm not looking at availability. I'm looking at, does it ping? Can I put a firewall on a packet path? Does it work at all? If it works at all, then we can start talking about the bars you need to get into the network. But of course, reliability matters. I can't make things worse just because I've made them different. They have to be different, and they have to be some way better, either for me or my customers. From our perspective, if you can, firewall's a bad example, but like a DPI type device, right? You see something weird going on in your LAN, you don't know what it is, it's coming from the internet. If you want to turn on a DPI box for a week, and you want to pay $2 a minute and run the thing and see what your traffic is, I'd like to sell that to you, right? So that's better for me, it's better for you, but the thing can't have, 2 nines for reliability. So yeah, ultimately that's important, but I want to stand it up and see if it works at all. And then we could talk about, carrier grade, whatever that means. Does that answer your question?
I have a question. So in this session, we're talking about kind of the future and what the future holds. I mean, we hear a lot of different protocols and platforms and systems bantered about. Open flow, open daylight. And as network people, I think we like to have some standards around things. That's what makes a USB port work, or a power plug into a receptacle, supply the proper voltage. In the lower levels of a system, like transportation or transport of data packets, you need some standards. But we hear that the IETF is slow, some other traditional standardized methods or methods of standardizing network protocols are slower than how SDN is moving. So what do you think, if you were to bet on a horse or bet on a protocol living a long time, which protocols or platforms would you guys vote on thinking might have the most longevity? Because I think that could be a barrier to companies wanting to embrace SDN, is that the industry is so fragmented, they don't know what to bet on, so they're in this analysis paralysis situation. So from each of the panelists, I'd like to hear what you think is the protocols or platforms that you think will have the most longevity that then would be worth a company investing on developing and building out a system around?
I vote RIP.
No, not an option. That wasn't one of the choices.
I think.
You mean RIP v2 then?
Yeah.
Okay.
Yeah.
Next
so,
gen.
So after I just vehemently agreed with your overlay disparaging remarks, I will say overlays are a really good way to position that there, right? So yes, we all started this SDN adventure a few years ago with the Stanford Divined architecture and looked at OpenFlow to manage a bunch of switches. And then we quickly realized that none of the switches could do that. And the ones that could weren't necessarily scalable or usable or available. And so overlays sort of became the de facto way to get that done, at least in a data center right away. And I still think it's a valid approach for a lot of architectures and a lot of services, where I just use an IP tunnel. And what we're saying here isn't necessarily some new protocol. It's just IP tunnels. GRE, VXLAN, which if I take away that messy multicast-based control plane from VXLAN, it's just an IP encapsulation method. It works pretty straightforward. So, those things are relatively safe. And then how I interact with the network, there's routing protocols that do that really well, and most all of us that are building products in this space are doing things with BGP and others to at least share information and interact in standard ways, because we know we can't come and ask you to build a new network for us. So, it's not as risky as it might seem in some cases.
Yeah, I mean, let's be honest, we have way too many control protocols today. I mean, when we're talking about this SDN idea, at the end of the day, we need a way to program the forwarding table, or it might be multiple forwarding tables, but we need some way to push information down. I mean, look at a router. So take my router, gotta go configure OSPF, BGP, I'm running MPLS, so I have RGP, but also LDP because I'm doing some tunneling with some layer 3 VPNs, and I have all my different interfaces, so I'm running LACP, and the list goes on. And at the end of the day, most of those protocols are just trying to populate a forwarding table. So, I think your question has to do about, is OpFlex going to stay around? Is OpenFlow going to stay around? Like what, this TTP idea over there at the ONF, like what's all going to happen? I mean, I think it's clear that OpenFlow has some use cases. I don't think it's going to disappear, but it's definitely not the solution for a lot of problems people thought it was before. I'm not personally seeing a lot of OpenFlow deployments. We have a few, but 10% maybe are the stuff we do. OutFlex is a new one, so I can't really comment on that. I don't work for Cisco, but I think we're going to see new stuff that we don't even know about.
I had to take a stab because you wanted everybody to stab, so I'm going to stab your question. You give me BGP, IP, and MPLS, and I can do anything, right? And then there are several ways to control MPLS. Maybe I don't need them all, right? There's the LDP, there's RSVP, there's BGP flavors, there's SR, there's whatever will come up next, right? There's OpenFlow to program labels, perhaps. I don't need them all, but give me MPLS for some kind of overlay, tunnely thing. Give me IP for endpoint identification, and give me BGP for policy. BGP is a political protocol, right? You can't do that with, people try to do it with OSPF, and it always breaks. Give me those three, and I can do anything. Maybe that's what.
And RIP.
Yeah, all right, you can have RIP. We'll do it inside. We'll do a RIP overlay inside BGP. We'll RIP SAFI or something. But give me those three. Give me those three, and clean slate, nice control architecture for it. Maybe I don't need anything else. Not at the routing forwarding level. Yeah, you're going to need MAC stuff and physical stuff and laser stuff, but that's, yeah, you can't change that.
It's interesting. I hear a lot of things about that OpenFlow is sort of losing traction and losing interest and doesn't scale and so forth. And yet, you look at ONF and the number of they're close to 150 prominent members of ONF right now. For various self-interest reasons, but it says to me that standard, while it may have its faults, is probably further along than a lot of other things. When we're talking about just that layer, between controllers and switches where we're pushing flows and such. Nothing else seems to be as emergent as OpenFlow right now, from what I've seen.
In terms of the configuring switch router protocols, you're probably right. The problem is they keep trying to extend it to, and Disclosure F5 is a member of the ONF, and I'm on the Layer 4.7 discussion groups and whatnot, but I just kind of look at some of the work they're doing, and it feels like they're trying to build the Emacs of southbound protocols. It's getting to be so complex and convoluted, specifically because we have so many self-interested parties trying to get their stuff into it, that at some point something's got to change there. So I'm actually not convinced OpenFlow as we know it today is what's going to survive. The concept maybe, but what we see today, I think it's got to have a major rewrite. And then the other space, you have really what I'm interested in is not necessarily how to control and extend the routing tables specifically, but it's more how do you orchestrate all the pieces together. And there we see the problem is, so my answer is OpenStack is splintering. It's very useful, but it's splintering. So again, in none of the places do I think there is a technology today that will have say 20 years of longevity. Before all said and done, we're going to see something else that's going to emerge from the chaos that we have today. But that doesn't mean you can't start building SDN deployments today. You can make a lot of leverage and mileage off of it. And that's kind of the point. Once you've centralized control, you can start doing some very powerful things.
I think it goes without saying, right, but I'll say it anyway, that, right, IP wasn't the first networking protocol that came along, right? It wasn't like, oh, suddenly somebody invented networking protocol and was perfect. So, I mean, we had lots of different protocols and whatever, and IP was an evolution out of a lot of those different things. And I think the same thing with whether it's OpenFlow or OpenStack, we're going to have a lot of different starts. Right. Hopefully, we will learn from all of those, and at some point, being humans, will stumble across something, have an aha moment, and it'll be, hey, that's really cool, and it will last then for 40 years.
Right.
And that'll be great. I agree with you. I don't think that OpenFlow or OpenStack are that. I think it will be something that looks maybe very different, but is going to have some underpinnings of what we've accomplished so far. And I just don't think we're there yet. I think it's still a greenfield. We're still learning how to build all this. I would really love to see this concept of there are sort of forwarding boxes that, as you were saying, I could assemble those in ways that are necessary for my network, and it's not just about how do I change the forwarding engine in something. It's about how do I actually change the characteristics of this thing that's out there, and it needs to be something different because suddenly I'm driving a bunch of video through it, or suddenly it's just a bunch of sensors at the other end. That's a very different box at those things, and I would love to find a way that we get to a design where that can all sort of morph as necessary.
Yeah, it's the policy piece of it.
Right.
So obviously, Yang, if someone wants to do a little research on that one, it's a very talked about modeling piece. But I think you mentioned that it doesn't solve like, okay, great, it's kind of like SMP. I have this thing, this structure, but like, how does it work? Is there a wire protocol? Like, how do I get policy from box A to box B and box C? And that hasn't happened yet. I mean, the protocol doesn't exist yet. I mean, there's several of them that work at Conf if you can extend that one, but we don't know. I don't know.
Well, I think there's a deeper problem with things like that, which is you express a policy, great. How do you map the semantics down to the data plane?
Right.
Right.
That's where all the magic and all the complexity really is.
Sam?
Put a disclaimer first. Was it one with OpenFlow?
You're going to tell me how you did that.
The reason why I say that is
That's a good idea.
OpenFlow is a protocol, right? So the SDN or the initiatives like Jeff was mentioning by the ONF are pretty much surrounded around the OpenFlow protocol as such, right? So if you consider OpenFlow as a replacement for, let's take IP, yeah, that's a long shot, right? But the momentum, I think the way I see it is not just the protocol. If you put the protocol aspect aside, the way how you want to solve the things, I think there is a good momentum at ONF for sure, right? And if you take ITF, for example, it's standardization, right? So I think there is definitely more traction there, but coming to the OpenFlow as such, if you want to, you have a solution and which is called OpenFlow protocol, and you want to build solutions around that, I think we are doing the inverse. Like, don't find problem just because you have the protocol. So I think that's where I think the problem is.
Cool.
Maybe one last question is takeaways for everybody who is still here, just wrapping up the day. Any recommendations for us or takeaways again from each of you? Thank you.
I'll start. Why not? Educate yourself. I'm big on education, so I think a lot of, change is hard. No one really wants to change, and change is really scary if you don't really understand what's causing that change either. So I think, we talked a lot about, different organizations. There's a ton of them even in the open source world, but, get involved and educate yourself. Because I think you'll find that if you wait around for someone to tell you the answer of SDN, you're going to be waiting around for a long time.
Yep.
So, it's also a huge spectrum, so you can't tackle all at once. Pick the thing that interests you the most and educate yourself on that.
I would agree. I would say start with what is your fundamental business problem that's not being solved today. Look at the marketplace and choose the tools that solve the problem, and then just go do it. And tell all the investors and analysts, whatnot, that you're doing SDN, because you are. But realize that it's really, at the end of the day, it's about solving your business problems with whatever tools you can get your hand on, because if you wait 10 years, you won't be in business to care.
So actually, to combine your two, and that is, focus on whatever the, it's not about the technology, right? And it's about solving someone's problem, or whatever. And I would just say it this way: is define SDN however you want and do it. As you did, you've already done it. You've been doing it for however many years. And because frankly, SDN is going to be, it's eight blind men in a room with their hand on an elephant, right? It's something different. Everyone's describing something different. And frankly, it doesn't matter. Whatever your piece is, wherever, if it's you're defining the API, if it's defining how to do forwarding structures, how to manage forwarding structures, how to do something, it's all SDN today. And it doesn't matter. So just go out and do it and claim you're doing it and get a boatload of money for going out and doing it and solve someone's problem. I don't try to say what is, I need to do the SDN. There is no the SDN. It is some aspect of this huge thing called SDN.
If you're a network engineer and you're a hands-on kind of person, go play. And it's easier now than it ever was. In the old days, you used to have to go buy a bunch of used Cisco routers on eBay and set up your CCIE lab. Now you can download VirtualBox or VMware Fusion or something on your laptop and get the latest build of Open Daylight, or stand up a little small OpenStack distribution in a VM and play with it and see how it behaves and see what it looks like and see what it does. I don't work for Viata anymore, but they still have an open source free router with a really nice CLI on it. You can set up and start doing some interesting routing things and play with the API and think about how you might script routing topology changes and script configuration models. And then once you kind of understand those methods, and go take a Python course or something if you're not a programmer, because you can do that for free too. And then just try it out. And then you can start to translate that to your Cisco CLI or your Juniper NetConf interface or whatever it is you're using. But just go play with some of these things because it's easier than ever.
And I would say, even beyond educating yourself, participate. That's the great thing about open forums, and open protocols is you can contribute. Whether that's ONF or IETF or whatever, but take your problems to them, and make sure that your problems are the problems being solved, or at least being included in problems being addressed.
I want to add something right to that real quick, just a specific thing. Conference passes, so the OpenStack Summits are a blast. They're a really interesting conference. There's a lot of interesting people there and exciting topics, and the parties are good and it's a good time. And the next one's in frickin' Paris, okay? So, you know, you can't complain. If you're a contributor to OpenStack, you get a free pass. You don't have to buy the conference pass. And you don't have to write code to be a contributor. You can be a documentation reviewer and go in and find 5 or 6 spelling errors, or if you speak a foreign language, help with the translation effort. And that's a couple hours of your time out of the week, and you can earn yourself a free pass to the conference.
So, and then just one marketing pitch for IPSO. If you want to make some money, IPSO, we've announced our next challenge. The only bar is you build something that has something to do with IP and is innovative, and you can win 10 grand. We gave away 10 grand to a company that built a IP-enabled urinalysis cup. It was amazing. So you actually pee. It was actually the pee on IP. So check out the IPSO challenge, and that's all I was saying. You can win 10 grand.
Throw my 2 cents at Ogie here. I'm going to take it a little different direction and not talk about the business, but talk about the people. Russ made a really good point this morning about the half-life of skills and how it's getting smaller. And I think there's a lesson to be heard from that and drawing an analogy to medicine somehow, right? Back in the day, before you had a doctor, you had a barber that yanked your teeth, but then you had a doctor, and then you had specialists, and now you've had subspecialists, and branches and branches and branches and branches, right? That's the way this stuff is going to go. And I don't ever want to be the guy, like the last COBOL guy standing, or the Betamax guy, or the 8-track guy, right? And I go back to my point about ripped jeans and median age of the room. You got to keep moving. You can't get complacent. You can't sit back. Your half-life is 18 months, and you got to subspecialize and subspecialize. Find 2 things you're good at in a job that involves both. People will pay you for it, and you'll like it. I don't know. It's worked for me. It's worked for people I've told it to. It may not work next week. I don't know. It's the best I got.
Thank you all.
Thank all of you for coming.
And for lasting till the end.
Yeah, I know.
Yeah, we're